join this awesome session for today. Um, I know you all are aware, but sometime in the last 3 weeks, um, we began with a series which we've been looking at for the past, would I say, maybe this should be the third session. We've been looking on the series on topics like this regarding Kubernetes. And one of the reasons why we are focusing around this is because we believe that as much as possible and as the depending on the level you are at, with your Kubernetes journey, we believe these are topics that are essential for your growth, right? That you would need to be, will I say, get to that expert level. And that's why we are proceeding on this series of topics. Now, aside this topic, we also have like a list of topics we also want to cover, right? Which we'll be discussing with the community as the time goes. But for now, let me take some time out to just introduce the awesome people we have or speakers we have in the house today. Um, my name, of course, is none other than Promise Nwachukwu. I'm MVP for Microsoft Azure and also a senior DevOps engineer. And firstly, I have in the house here my awesome colleague. Chidebere has been someone I've worked with in quite a while, and here in Acho. And of course, today we are going to do justice to this topic. We would like to break it down and explain to the best we can. That's what I would say. But sure, let me take some time to introduce Chidebere. Chidebere has, I would say, has been that wonderful engineer. You know that colleague you always work with every time, and you're like, he gives you all the insight, all the vibes, all the challenges you need to do your work, right? So yes, that's my colleague Chidebere. He's been in the industry for, let me say, over 7 years now, right? And he also enjoys sharing his knowledge. He also enjoys avenues like this where he's able to help break down concepts. So yeah, on the floor is Chidebere. Chidebere, do you have one or two things to say?
Okay, thank you, Promise, for the awesome introduction. My name is Chidebere, and as Promise rightfully said, we have worked together for years now. And then today we'll be dealing with this topic, linting Kubernetes clusters to enhance security compliance. Please stay tuned as we'll take you on that ride.
Awesome, awesome. Thank you very much, Chidebere. Also in the house today, I have an awesome, wonderful colleague as well, a thoroughbred engineer, right, who has been, you know, devouring topics like this for a long time now, and also an awesome colleague of mine. He's also a senior DevOps engineer, a community leader, an expert in the industry as well. I'm speaking of none other than Iheanacho Chukwu. Iheanacho, do you have one or two things to say to us?
Yeah, thank you for that awesome introduction. I wanted to say, everyone here, thank you for joining, for putting out time to as well learn from us. And we also try to put in that abilities to reach out to everyone and answer all the questions. So thank you for joining. Let's move into the session. Thank you.
Awesome, awesome. All right. So, yeah, without further ado, and awesome introductions, introducing the awesome people I have in the house today, I believe we can then commence with the topic. And today, what we are basically focusing on is security compliance with Kube-linter. And I'm sure a lot of you have maybe had one or two things to do with Kubernetes. But the interesting thing about the fact that Azure is a platform that not just provides managed services for you, but then Azure is also a platform that works with various providers, right? So it has its own managed Kubernetes platform, right? But at the same time, it also allows or gives room for other providers to, will I use the word corroborate or collaborate with the service it's offering? So Kube-linter is one of, I would say, I call it a third-party tool or an open source tool, which you can also use on your Kubernetes platform to provide some form of security compliance with your development work. But let me just give a brief intro on this, right? So on my slide here, we are going to be talking basically about, we'll do a short intro on this, the security challenges people would likely face in a Kubernetes cluster. We will talk about what Kube-linter is all about, its key features, how does Kube-linter work, enforcing security compliance with Kube-linter, and then we would have a demo session today, right? I know the time is not much, but sure, we will make maximum use of the time we have. All right. So, like I was talking about earlier, I said Kube-linter, of course, there are definitely scenarios where you have some security challenges on your Kubernetes cluster. And you're like, okay, what is the best approach to go about this? Kubernetes, like we know, it's just generally you are dealing with containerized, it's a general containerized platform, right? Where you are containerizing your workload and making everything available in simple forms as pods, right? So your pods are like the medium which you establish that communication, or let me say those little bits. Okay, in breaking down your workload in your Kubernetes cluster, you have your nodes. Your nodes are like the hosts that help you, host your resources. Now, the resources in question which you are hosting are some things like your pod. Now, your pod, for it to be able to function well, has to take resources from the host. In this case, your nodes, right? Takes things like CPU, memory, connection between your nodes, right? Also helps with the connection of the pods itself, right? When you've configured your CNI on your cluster, that helps with the networking of the pods. Now, there are, of course, quite some things you want to also consider when it comes to the security of your Azure Kubernetes cluster. But then we have this interesting feature which we are about to explain to you on how Kube-linter actually works. Now, we will take a look at this. What are the common Kubernetes security issues you would likely face, right? One are insecure container images, right? Misconfigured RBAC configurations, your role-based access control. This is on its own is something you really want to be very, very careful of. Reason is this. I will give you an instance. Assuming you need someone to just, let me say, be able to manage a pod in a namespace. And for some reason, because you misconfigured your RBAC configurations, you gave this person the ability to be an admin on that cluster. And because probably this person wasn't really sure or probably was making a mistake, and then he deletes maybe an entire service or he deletes an entire application running on the cluster. Now, by default, if your RBAC role was configured properly, he wouldn't even have the permission to be able to carry out this task, even if he was making a mistake. So these are important security challenges you also want to be aware of and how we can tackle them, making use of what Kube-linter. Now, another thing you also want to talk about, just like I spoke about earlier, is the unrestricted network policies. This is something you don't want to play with. In your Azure Kubernetes cluster, you should have policies that dictate what communication should communicate with what. Very, very important. Another thing is what? Containers running as root. Oh no, trust me, that is something you don't want to do. You don't want to give your containers that permission to run as root unless there is a specific reason that that container needs to run as root. And that is in some very, very rare case. Like it is not even advised to be done. But in a case where that happens, then that is exceptional, an exceptional scenario. But by default, your container should not be running as what root. And the idea of this is to prevent unwanted scenarios and to prevent, let's say, giving permission to your container to be able to achieve something it's not supposed to be able to do. The next thing is what security compliance becomes critical to ensure what adherence to what security policies and prevent breaches. In a few little stories I shared earlier, I just giving you a simple scenario where if you don't have any security policies in place, then a breach is like almost inevitable. So for you to avoid scenarios like this, one of the things you do is that you put in security features in place to ensure things like this don't happen. Now, I'll be going over to this, right? And just give you a brief intro on this, and then my colleague will take over from there. But generally, what is Kube-linter? We've been talking about Kube-linter for a while, and I'm sure you're wondering what is really this Kube-linter all about. Generally, it's just an open source static analyzer tool for Kubernetes. And sure, it was developed by what Stackross, now part of Red Hat, right? And what it does generally is it gives some analysis of your cluster. It helps give that security analysis of the cluster and gives you also suggestions on how you can help improve your security posture. Now you can see here it says it identifies what Kubernetes YML manifest and Helm charts that don't follow security best practices. And what is the purpose of this? What's one? To ensure that your Kubernetes configurations comply with what security standards, also to help with automating the detection of common misconfigurations before deployment. So if you've actually heard what we spoke about earlier, you would realize that having a setup or a configuration just like Kube-linter in your Azure Kubernetes cluster goes a long way. It goes a long way in the sense that even if you are a novice to the Kubernetes platform, you get to see a lot of suggestions that would help you improve your setup in the cluster. And at the same time, there's something about you didn't know about this, but later you now learned about it, and now you know about this. And then now you even have more information. So what it now helps you do is it even helps you now to be more equipped in terms of the security knowledge you have regarding the challenges you can deal with in your Kubernetes cluster. So at this point, I would hand over to my colleague Ian Acho to proceed from here and then give you more details on Kube-linter, and then we proceed from here. Hello, Ian Acho, can you take over from here?
Thank you very much, Promise.
Awesome.
So we are looking at Kube-linter, what as a static analysis code tool. And what that really reminds me of is its ability to really, drill down things without having to personally run your code in, say, in a container or in, say, production in your live environment, wherever it is. So static code analysis really allows you, okay, to kind of have a feeling of your code, thoroughly check the configs, check for best practices, check for vulnerability, check for image mutability, checking as root, and all other misconfigs. So this is really a very good advantage we should mention here. I just need to continue from there. So looking at the features of Kube-linter. So it says it really helps us to scan YAML and Helm charts. What are we actually referring to here? Because Kubernetes is a declarative, you have a declarative way of managing Kubernetes through YAMLs. And when we say YAMLs, we're talking about manifests. And these manifests are what makes up both for Hemchat. Hemchat is more of like a package manager where we have a lot of templated YAMLs behind the scene. Okay. So what Kube-linter will be doing in that regard is it goes through this YAML, all YAML files. Basically, Hemchat is also a YAML file, kind of. So it goes through the YAML files, it looks at the configs without needing to run in a cluster, which is why it's a static code analysis tool, right? So in terms of the pre-checks, it has its own standards policies that it could run without necessarily having to costume to your organization demands. And this is the pre-checks we're talking about here. So it's some, like for instance, now we have container running as root. As Promise mentioned, this should never happen. Like, forget about the rare cases. It should never happen, because if container should run as root, it breaks every principle of port security. Okay, so I also have missing read-only root file system. We shouldn't allow our file system to be writable in any circumstances. Okay, then insecure host paths. This is more of like, you know, allowing your port to be able to reach your hosts, have access to the host system itself. You should just have access to its own containerized environment, not your host paths. Then, like we mentioned, we have standard checks or rules. I also have it to be able to customize the routes. This is actually so because we need people, every organization has its own standards or whatever they are particularly concerned about. So having a customizable policy or rules allows one to tailor-make your scans to meet the demand of the organization. And wow, awesome. Talking about the CI/CD integration, Kube-linter is really killing the game because it helps you to move all your development work. I call it shift left. Okay, allowing you to have early detection. You don't need to run this code or take it to live before you notice that there's an issue. You want all of that to end probably in the development environment, right? What this means is we are actually going to be informed of vulnerabilities quite on time, early detection. We're also going to have a lot of reduction in kind of costing as well, because you can know if a project or an application is really secured, is secured. Because if it's not secured, probably you take it to live and someone breaks into your system and does a lot of things, you're going to lose money. I'm going to also run into compliance issues. So it's not just having a great application. Do you have a secured application? So it's really something we need to be very aware about. Then it's open source. Everyone can contribute to this, the Kube-linter. Now we'll just move to the next slide here. How does Kube-linter works? Like we mentioned before, it has like a it has a flow system, a workflow. What's the workflow like? It gets an input YAML files, which could be what? Normal YAML of Kubernetes or Hemchat. Like I mentioned before, they are all YAML files. So Hemchat is more of like a templated YAMLs. Hem is a package manager that has the ability to manage all of those YAML combined together as an application. So it takes the input, which is the YAML files. It does its static analysis, run the security checks. We have the operational checks, the custom rules. It does all of those good stuff. And what does it do? It analyzes against the standards, and we have a printable output. Okay. It produces a report with violations, including recommendation for a fix. Let's say, for instance, we have things like running as root. It's going to say this has violated this policy, and we also need to make sure we are able to run as a non-root. So it gives you the violation, also gives you the recommendation for a fix. It produces the reports as an output, basically. And in terms of integration, it's really very flexible. You know, we can decide to run in your local system, you know, install the application and start doing your code scanning. right from your local system. You can as well decide to run as a Docker image. It gives you that flexibility, which is really a very good stuff. And you can also as well integrate all of this good stuff into your workflow, save on Azure DevOps, GitHub Actions, GitLab, CI, Bitbucket, whatever it is. Okay, so it's very flexible. It's welcoming. Really, it's an open source stuff, so we expect it to welcome everybody. So that's expected. So the flowcharts, having said that, it gets the input, which are actually YAML files or Helm charts. It does the Kube-linter stuff, being a static analysis, go to. Then it fetches our results, which is the static analysis. Okay, then it publish those results, which are violations and recommendations. From here, I would like to pass this on to my colleague, Chidebere, to continue this discussion and take us to a real demo of how we can integrate this to Azure DevOps pipeline. Okay, Chidebere, you want to continue from here?
Oh yeah. So thank you so much. Despite the time constraint, I believe you guys have really done a great job in explaining the details about Kube-linter and what it is used for. So on my side, I'll be taking up a demo section on deploying Kubernetes resources and also show you how Kube-linter works in scanning the YAML manifest file that will deploy those resources and then giving us some recommendations of error messages. So I'll share my screen from here. Just let me know when you can see my screen, please.
Yeah, I see your screen.
Onto a screen, yep.
Yeah, I see your screen now.
Okay, good. So from this interface, we already have a working pipeline. However, I'll repeat that and then give you an overview of how it works. But before we proceed to that, I would like to go to the repository and explain parts of the code blocks that we have and what they do and how the Kube-linter is being implemented. So first here we have the code structured into two: one deployment via Helm chart as package manager and one sample deployment where just a direct Kubernetes manifest file. So I'll explain the pipeline and then the code structure of the manifest files, and then we'll run a pipeline. So here is a demo of this pipeline script. And then from the start, you can see that this pipeline is triggered when there is a commit or a pull request to this main branch. And then the second stage is declaration of the variables. So in this scenario, I declare two variables making reference to this directory that deploys the Helm chart package and the directory that deploys the Kubernetes manifest file, which is this default working directory / the KA sample, which is this, and then that of the Helm chart. Then the third stage here is the pull image. So in our previous sessions, we have explained how you can use a Microsoft Azure hosted images, or you can have a self-hosted image of either Ubuntu or Windows VM, and then you can reference that to run your jobs. Then the two major steps we have, which is where the implementation of Kube-linter comes into play, is one, the first step that will run the static code analysis on the Kubernetes manifest file, which is this, and then the second script that will run the static code analysis on the Helm chart package. So the explanation of this is, so this runs the Docker. This particular command, that's Docker run, yes, specify the tool, that's run the Kube-linter to inside the Docker container. And then this V, as we have initialized this variable here, which is the directory structure where the manifest file is. So this mounts this directory structure into the container as this. So it will pick this directory and the file in it and mount it into the Docker container as .yaml, and then this specifies the official Docker image for Kube-linter, and this command length executes the actual linting or static code analysis on this file, which has been mounted into the container, and then continue to run. Display name is just you can give it any desired display name to understand what is going on in the code, and then continue to run on error equals to true. You can put it to false. So what this does is, if the pipeline fails, if there are some errors detected by Kube-linter, it can still continue to run, but it will give you a pointer to that. This is only used in a demo or test environment, not on production environment. So the second script implements the same thing, but on a different folder structure, which is on the Helm chart. That is, run that in a Docker container image, mount this directory as this in the container, and then reference official Kube-linter Docker image, and then execute the actual command, which is length. So I will now go a bit into the YAML that we have, the Kubernetes manifest file that we have, which is actually what this linter is going to analyze and give us the analysis. So here we have a sample manifest file that will deploy resources to Kubernetes cluster, which the first section will just be the pod definition. So within this pod definition, you specify the API version, then you declare this resource to be like a pod, and then you include the name, which is this, just for the demo. Then the second stage for this is the pod level security. So the pod level security is where we specify this to run as a user, because running that as a root user increases your security vulnerability or exposes the environment. Then the third stage here will be the volumes, so which specifies the name of the volume, and then initialize an empty directory. This is just like an empty directory or temporary directory created within the container that gets deleted immediately the pod terminates, right? So we have the container specifications, which is specify the name of the container and the image. This image is making reference to official Kube-linter Docker image. Then we have the resource tags, which specify the memory usage, the memory limits. So this memory limits is just to limit overuse of particular resource. Based on best practices, good to specify the limit of which your CPU or memory is being utilized. Then you have this command, the command options. This command option is basically for a demo, which keeps the container running for about an hour. And then we have the volume mounts. So this mounts this volume into this part, data.demo. And then we have the security context. So within this security context, we have allow privilege, so escalation to false. So if you allow this privilege escalation to false, it's just to kind of prevent processes in the container from gaining more privileges other than the ones assigned to them. Just like a role-based access control, limiting access or giving least privilege access to containers. Then we have the second option of the security contents, which is read only root file systems. So set to true, though it's commented here, I'll just show you how it works. So this the purpose of this read only root file system is to enforce read only root file system. So preventing some changes to be made to the containers. So if this is set to false, then changes can be made to the containers which are not allowed, just like my colleague Nacho explained. So the restricting access of usage and what modification that can be made on the root file system. So with these configurations and this is a working configuration manifest file, but I commented few parts out just for us to test the functionality of Kube-linter. So I'll proceed to triggering the pipeline, and we'll see if Kube-linter will be able to pick any error here, and then if it will also give us a recommendation on how we can resolve the issue. So let's dive deep into the pipeline. So in our previous sessions, we have done series on how to create pipelines and the rest. So we have created this pipeline. I'm going to trigger that now, but just a minute quick overview in case if you are new to setting up an Azure pipeline. So we can just select a new pipeline from here, then select the source of your repo, whether Azure repo or Github and the rest. So here you see that it's giving me all the repos because we've connected our Azure our GitHub to this DevOps environment. So we are using this Kube-linter. Once you select that, then it will ask you whether you are using a starter pipeline. That is, are you writing your YAML script for deployment afresh, or you have it already? We are using existing. So with this existing, we will be asked to select the parts where that exists. So this is just a quick overview on how you can set up your own pipeline. So let's go back and run our pipeline and see how Kube-linter works. Yes, run new pipeline. Okay, good. Let's just give it a few seconds or minutes, and then it will come up. Okay, good. It's running. Okay, good. So the if you remember, I explained a part where it shows let this run even if it fails. So if you do that way, let me edit and remind you that. So continue on error. So that is why this pipeline got to this stage without breaking. So assuming it's set to false, then it will stop here. The pipeline will fail here. So, but this is only used for demo purposes. So let's check the details of the error messages. So first, on this, the first pointer to this error message is on yaml/pod.yaml. And then what is the message all about? Object number namespace under the security context. If you check this file under the security context, then we have container this, which is the name of the container, does not have a read-only root file system. So we have to go there, know this remediation, set read-only file system, because we commented that part. So the remediation and the suggestion that Kube-linter is giving that we should set this to true. Then the second error message is within the same file, pod.yaml, which is still on the security context, and then the container, this container name has memory limit 0. So I think, yeah, the remediation should be to set remediation is set memory limit. So the first thing we have to do is to check this file, these two files, and make these two corrections and see what happens on the pipeline. So let's go back here and then go to our repo, and then this is the pod.yaml. If you take a look here, this is YAML file, which is already initialized as a variable for the Kubernetes manifest file, and then the file attached in it, the pod file, which is this. So we have the first error message showing that this security context does not have a read-only set to true, no read-only. So we have it here commented out, which is read-only root file system true, is commented out. So if we edit this error message will clear off. Okay, the second error message in this category is memory usage ritualization. Then we should set memory usage to true. yeah, which is already here, but commented for this demo purpose. So we'll comment it and set a memory limit. So once these two corrections are done, then we can commit. So just updated. The pipeline will now run. This will clear. Then we'll edit this. Commit to that. Okay, the pipeline is triggered already. So, but while this one is running, then let's analyze the second error message on the Helm package manager. So on the Helm chart, you see we have about 4 error messages. So found 4 lint errors. So on the chart, which is already initialized as a variable, directory initialized as a variable, then this under the template and then deployment file. So I think all these 4 errors are coming from the same file, deployment.yaml. So what are they talking about? So if you check on this under test release Helm-chart sample, then kind deployment, the container Helm-chart sample does not have a read only. So we have 4 error messages. One does not have a read only root file, which is similar to the previous error we have on the manifest file. The second is Helm-chart is not set to run as non-root user. So we have to set this to run as non-root user. Say the remediation set run as user instead of as non-root. Then we have Helm-chart sample CPU, that's memory utilization. So you have to set a memory unit. Then the second one also, the last one is also a memory utilization, CPU and memory utilization. So we have to set limit on the memory, have to set limit on the CPU, and then we have to set to non-root user and then read only. So let's go back to our file and then edit this. So come down to here under template. If you go back to this error message, you see the pointer is clear. Under templates, deployment.yaml. So under templates, deployment.yaml. Remember that this same chart is initialized as chart, as initialized as a variable and name chart. So good. So here we have the read only file system commented out. We have run as non-root user commented out. So once we uncomment this, that will clear that error message. And then we have memory limit, CPU utilization and memory limit. We uncomment that out again. And then that will clear our error. So this just basically, depending on your own configuration, this for the demo purpose. So if you have any error within the script at all, or either by omission or you commented or you did not even add it at all, Kube-linter will be able to point that out and give you a recommendation on what to do to resolve that. So let's comment this and see how the pipeline works. Then let's go back to the pipeline. Yes, the previous one. If you check the previous one, I know. Yes, the previous one we did, you see, the first message we corrected, it passed. Remaining the second one about the Helm chart, which we just triggered now. So this will also pass now because we have corrected the error message. So let's go back and follow that up. Good. So as you can see now, the Kube-linter check for the Kubernetes manifest file passed and is showing download complete. Check. So Kube-linter, no lint errors found. So it's showing that your manifest file is in compliance with security checks and then best practice. Then we check that of Kubernetes Helm chart, and then you see that no lint error found as well. So it's in compliance with best practice. So when this is done, you'll be rest assured that your manifest file or the resources you are deploying to your cluster meets the best practice or the recommended ways to deploy your resources to Kubernetes clusters. So with this done, if you have any question on this stage or any other modifications or whatever then you want to ask on this topic, please go ahead and then ask, and we'll try our best to do justice to that. Thank you.
I think Emmanuel has a question. Emmanuel, can you proceed with the question?
All right. Yeah. Thank you so much. So I noticed that when you were running the demo, okay, so you made a comment where assuming there were some errors that were found on the Kube-linter. Okay, so I don't know. I don't know. I'm just asking. I believe the best practice should be that I should not proceed with how will I put it, deployment. Okay,
Oh, yes.
so right. Okay.
Yes, I explained that this continue on error is only for demo or test purposes.
Okay.
It shouldn't be used on a live environment, right?
Okay.
Because why I did it continue to true is because we have two steps in the pipeline, right? We have two steps. One will link the manifest file for Kubernetes, and one will link the Helm chart. So if it fails at this stage, we will not be able to get details for this, right? So I have multiple linting, and that was why, and this is demo, and that was why I allowed it to pass, and then to be able to troubleshoot all of them together. But in a situation whereby you are working on a live environment, you turn it to false, so you be able to troubleshoot one first before proceeding to the other.
Okay.
So that is actually the best practice, setting it to false.
So let me add something to that. So like rightfully said, you actually allowed it to fail and still continue because there are two checks. To add to this,
test environment.
Yeah. Apart from that, we can as well. I'm gonna surprise you with this. I won't sound stupid, I promise you. We can as well decide to even fill that in, say, in our proper pipeline. We can decide to allow it to pass. Say, because I want to publish that result. So basically, if I say fail and kill, I won't have all the output result printed to somewhere very decent for me. Say within Azure DevOps, for instance, for proper tracking and any other integrations to other platforms, right? So I can still decide to allow it to fail, pass with failures, because I want to publish that result, that test to somewhere very safe, which is one of the practical scenarios we should do. Then you cannot decide to fail the pipeline after publishing it, which, for instance, test publishing, test publishing can do that for you. If it sees that there's an error, it fails it after publishing. So that way, you have all your results in one place, carefully tracked, and at the same time, it's failing when it needs to fail. So it's not as if it's not a best practice. It depends on how you want to apply that. And in templated pipelines as well, you might decide to have all of this in a stage, okay, which also makes it very common, very practical to allow it to pass with failures. So it all depends on how you want to use it. I won't say it's wrong to not fail it. No, I won't agree with that.
Okay. And also, let me say, in scenarios where you aren't sure if that is something to do, if to put tags like that, continue error and continue on false, there are also tools which you can have on your system, right, on your local system, that could help to check if those are things you should actually implement. Say, for instance, if you have maybe, for instance, I say maybe a pre-commit installed in your system, and you did some configurations to check your code before it does a commit, it can also flag that symbol to you and say, hey, I don't think this should be true, and can actually stop you from committing that code. Right. So that's another way also you can use to flag this. But I think in this case, we have done this purposefully so that we can carry out the tests and so that you can be able to see that the pipeline works fine.
Okay, cool. All right, thank you. I still have some other questions. Okay, I just need some clarification on. Okay, so I don't know, Chidebe, I don't know the possibility on. I can see that you stopped sharing your screen. So, but just a
Okay,
quick one,
let me
yeah,
share
for
again.
the. All right, thank you. So for the Kubernetes YAML file, okay, which you shared, I discovered that we have like two steps below, and I noticed that yeah, so these last two steps, okay. So I'm kind of wondering because here I could see that the image was actually being run from a Docker, okay. So and yeah, the first one was I don't know, that's for the analysis YAML manifest, and the other one is for the Helm chart.
For the Helm
So
chart, yeah.
okay, so I was thinking, I don't know how this Kube-linter works, but I feel that this is already Dockerized in a way, right? The Kube-linter. So, and all you have to do is just to pull the image from the Docker. So, in this case now, I thought we are just working just with, I don't know, a single Docker image, but here it seems that we have like double or two images or whatsoever that we are using or scripts.
Okay, yes. Yes, in this scenario, you can actually pull this image from their official Kube-linter image and then work with that. You can reference it via your pipeline directly.
Mhm.
Depending on, just like as my colleague explained the previous one, that it depends on a use case.
Okay.
And then this sample demo is just like, for instance, to show how Kube-linter actually works and then how you implement it, because this is basically a very simple sample stuff. So you might
Sample.
have a scenario where you are working in an enterprise environment and your configuration will be so complex, right?
Okay.
So you can as well write this script as a single template that will be used by multiple pipelines without you having to write script in each of your pipelines. So it depends, it basically depends on a use case.
All right. Thank you. All right. So, and one last one I want to ask because I noticed that um, when we run the pipeline, okay, it had to populate the errors. That's the Kube-lint Kube-lint had to populate the errors, and it seems that the only way we were able to review this was when we went to the run event. Okay, so I'm kind of wondering in an enterprise, okay, where we have like various teams in charge of this. I don't know, is there a mechanism where this errors that have been found can actually maybe be exported to maybe a file or whatsoever that maybe teams under the monitoring or can further have a look and see what actually happened instead of just having a look at it here from the jobs that were run. I don't know.
Yes. Yes, so
Okay.
before my colleagues proceed, I will just point out to the answer my colleague gave on Nacho gave on the previous question, that
Okay.
with this it depends on maybe your use case as well, because you can actually export this as an artifact and not
Okay.
have it displayed here. Then also in a situation whereby you have integrated some monitoring tools like Loki, Prometheus, and Grafana into this or whatever, then you can export all these logs. You can even get an alert on them instead of having to view that here. I think we had a previous session where you can even integrate a Slack notification to your pipeline and get, so you can train your script to suit whatever scenario you want and not have it displayed here.
Okay.
So I
Okay.
don't know if my colleagues have addition to that as well.
Yeah,
Yeah, I
it's
think
you actually yeah, go ahead, promise. Go ahead.
no. I was just to say, like, I feel like he covered most of the points there.
Yeah. So he actually nailed it. So it's just like, because we actually tried to talk about that scenario earlier on. So you can export your results, say within Azure DevOps or even integrate to other platforms. And yeah, it depends on your use scenario. Really, it depends. It depends. So yeah, that should really be it. I was trying to do something very quick, but it's not so neat. I don't want to show what will further confuse us. But really, you can add more things to what Chidi has done that will export as an artifact, allow it to also be available for further analysis, integrate it to other platforms. Things there's even Microsoft Defender, for instance, and other platforms. There are a lot of things you can do. Yeah, let me see if I don't know if this will confuse us, but yeah, maybe it's worth just sharing.
Yeah, please do.
Maybe it's worth sharing. No, I mean I didn't have a proper time to look at it, just on the call. So
Okay.
what I tried to do was to add like allow it to be published as an artifact. Okay, then I'm supposed to be able to view that same artifact results here. But what I have didn't really throw any vulnerability, so you won't see anything in here, right? So I just did that on the go. Didn't really have proper time to look at it. But yeah, basically this is one of the things we can do. Okay, we can export the result. We can make it available as a variable artifact here, right? At the same time, we can as well integrate it to other platforms as well. So they love possibilities. There's so many things to do, actually. So many things.
Oh. Okay. Thank you so much.
You're welcome.
Awesome. Yeah, I think we've actually covered this particular topic for today, and I mean, I think I'm happy with the result we're able to achieve with this and how far we'll be able to cover on this. So at this point in time, I think it will be a good time to round up the session for today. But of course, don't forget to follow our channels so that you can be up to date on the various follow-ups programs we'll be having from here, and you can participate in them as well. Trust me, we have some interesting lineups for you as well following this particular series, and we do hope that you do get some time to go through the calls or the videos in our channels if you miss them, or you are able to join us live on these sessions. But at this point in time, I would like to say thank you very much, and see you in our next session. All right, everyone.
Bye.
Thank you.
Thank you.
Yeah.
Bye. Cheers.
Bye-bye.
Bye.